Geometry honor students, so this is Mr. Chen again, and welcome back to my YouTube channel. So today I would like to talk about sections 11.4, and this one it's all about the surface area of a pyramid. So objective, find the surface area of a pyramid, or sometimes you can find the lateral area. So the difference of the lateral area, surface area, so the lateral area it's just that the area of the side, okay, of all those triangles there. And then the surface area, not only the lateral area, but also that include the area of the base. So the formula for finding the lateral area of a pyramid, it's always 1/2 times the slant height, which is L, and then times the perimeter of the base. So P that stands for the perimeter of the base. Okay, so one thing that I just want to point out. So P, which is considered the perimeter of the base. Okay, so the surface area, so again, it's not just considered the lateral area, but also you want to add on the area of the base. So the area of the base could be could be the square base, it could be a hexagonal base, it could be any kind of geometric figure base, any kind of polygon, okay, or it could be a triangular base, okay. So now, let's take a look at that one of the example here. So PRXYZ, it's a regular pyramid. Okay, so the midpoint of its lateral edges are joined to form a square ABCD. Okay, so that ABCD, so those are the midpoint of those slanted edges. And then PR is 20. Okay, so PR, the distance here, that's 20. Okay, so point it out, PR 20. And then Rx, and this one is 22. Okay, so it's a three-dimensional, it's a 3D figure. So as you can see that here, so the pyramid that consists with the upper pyramid and also the entire pyramid. And also you just dissect it into two parts. So the upper pyramid with the square base, and the bottom part here, it's a square base trapezoidal prism. Okay, so the way to find out the area, the lateral area of PRXYZ. So one thing that we need to find out here is that the slender height. So this one is just the lateral edge, it's not the slender height. So the slender height would be the distance from point P, the vertex, all the way to the midpoint of Rx. Or it could be point P to any side length of the base at the midpoint. Okay, so let's just make that line segment. So this one, you just bring it all the way down to the bottom here. Then that would be the slender height of this pyramid, PRXYZ. Okay, so let's just label that the slender height here. Let's give the name. So let's say this one it's L. So in order to find out what L is, so what we can do, we can zoom out this triangular surface. Okay, so it's a equilateral triangle. So for that equilateral triangle, so the slender height, which is the height of this isosceles triangle. So we do know that the slanted, the lateral edge right here, it's 20. So the lateral edge right here, that's 20. Half of the base, so half of 22, it's 11. So with the right triangle, so what we can do here, we can use that the Pythagorean Theorem to find out the slender height. So L equals square root of 20 square minus 11 square. So 20 squared, that would be 400. 11 squared, then that would be 121. And then once you subtract, so we do have square root of 10 minus 1, 9. 9 minus 2, 7. 3 minus 1, 2. So it's square root of 279. And according to the perfect square number, so 279, it's a non-perfect square number. So basically we can just leave it like that. Another thing that we can do, so perhaps we can factor it. So 279, it's considered, okay, so if you divide it by 3, so then that would be considered 93. Okay, so divided by 9 perhaps. Okay, let's just find out that number. 279 divided by 9, so then that'd be 31. So this one can be simplified with 3 root 31. So the way to find out the lateral area, again, using the formula, so then that'll be 1/2 times the slender height times the perimeter of the base of the pyramid. So 1/2 times 3 root 31, and then the perimeter of the square base, which is 22 times 4, because that's a square base. So this one simplified it a little bit. So 2 goes into 22 11 times. So 3 times 11, 33. So 33 times 4, or 12 times 11. Okay, so which is 2 times 1, that's 2. 1 times 1, that's 1. 1 times 2, 2. 1 times 1, 1. So it's 132. So then that'd be 132 root 31. And this one, the unit, so there's no unit involved. So this one can just say that it's square unit. Okay, or just leave it with the number. Okay, so now what about the other one? Find the lateral area of the pyramid, PABCD. So that means we need to find out the lateral area of the small pyramid here. So this one is quite similar. So we do know that all those points here, A, B, C, D, those are the midpoint. So by using the mid-segment theorem of the triangle, so we do know that the side of this square here, then that'll be 11. Because that half of the base, then that would be the mid-segments of the triangle. So 11, 11, all 11 for the side length of the square. And same thing happened with that, the slender height. So by using the proportionality, the common ratio is 1/2. So that means the slender height here would be half of 3 root 31. So the slender height for this one would be 3 over 2 times root 31. Because that's the common ratio, 1/2. And with the side length for the square, 11. So using that formula again, area, this lateral area of the pyramid, so 1/2 times the slender height times the perimeter. So it's 1/2 times 3 over 2 root 31 times 11 times 4, because that's the perimeter of that small square. So 1/2, the other 1/2, so 2, 2, 4 cancels out. So we got 3 times 11, 33. So 33 root 31. Square unit, or just leave it like that. Okay, so now let's see what else that we have for the pyramid. So the other one, example 2, each lateral edge of a regular square pyramid is 4, and the height of the pyramid is 2. So what is the measure of the diagonal of the base? Okay, so let's just make the pyramid. So it's a square base pyramid. Okay, so similar to the one that we have right there. Okay, so it's a square base pyramid. Okay, so it looks like this. And one thing that we notice, and the lateral edge, it's 4. Okay, so the lateral edge right here, that's 4. And we do know that the height of the pyramid this time, so the height, which is the perpendicular one, so let's just make the line perpendicular to the midpoint of the square base. Okay, so right here, and that'll be this one. So the height, it's always perpendicular. And this one, we do know that the height, it's 2. Okay, obviously the figure is not drawn to scale. So what's the measure of a diagonal of the base? So the diagonal, that means we're talking about this side length right here. So let's say that is D. So the way to find out what that is, so we can use that the special right triangle, 45, 45, 90 degree. If that's a square base, so that means the diagonal, it's always considered root 2 times the smaller base. So we got 4. Well, let's see right here. One thing that we don't know the side length here. So let's say this one is X. This one is L. Okay, so let's see. Things that's missing here for the square base. Okay, so another thing that we can figure out here is that the using this triangle, the cross-section area. Okay, so the one that's being bounded with the slender edge and the height, and then half of the diagonal. This one will be half of the diagonal, so let's say this one is L over 2. So the cross-section, that the one I just shaded here. So this one's 4 unit, and the height here, which is 2. So in order to find out this L, so we're using the Pythagorean theorem. Okay, yeah, for the square base, we're going to use that figure later, so let me just erase this one first. Just focus on the cross sections of that right triangle. So by using the Pythagorean theorem, so we do know that L over 2 quantity square plus 2 square, so that equals 4 square. So that means L square over 4 equals 4 square. 16 minus 2 square, 4. 16 minus 4, then that'd be what? 12. And then solve for L. So L square equals 30 multiplied by 4, then that would be 48. Square root of L square, then that'd be L. So square root of 48. So then that'd be 4 root 3. Because 48 can be written as 16 times 3 using the factor tree, so it's 4 root 3. And then once we find out this the slender height, the diagonal. Okay, so again, this one we don't want to say that. Instead of using L, we're using D actually. Because L, that would be the slender height. So D over 2, D over 2. Okay, so let me fix the variable. So the diagonal is 4 root 3. And now, what else do we need to find out? The pyramid slender height. So the slender height, so we're using that the right triangle. Okay, before we figured out that the slender height, so it looks like we can figure out the base, the side length of the square. So again, we do know that the diagonals already, which is 4 root 3. So we do know that this one's 45, 45, 90-degree triangle. So that means the base would be, well, this one would be root 2, 4 root 3 divided by root 2, using the special ratios. So the side length, okay, let's find out the side length first. So it's 4 root 3 divided by root 2. So once you rationalize it, or just divide it by root 2, top and the bottom, or multiply by root 2, top and the bottom, so you got 4 root 6 over 2, which is 2 root 6. So the side length of the square base, it's 2 root 6. And then using that, the right triangle, the slender triangle, and then we can figure out the slender height. So half of the base, so half of 2 root 6, which is root 6. And then this side length here is 4. And using that, the Pythagorean theorem, so we can figure out the slender height. So the slender height, let's say it's L. Okay, so again, just want to get more space for this one. So got to be careful with that. There are a lot of cross-section area. They all consider right triangle. So we're basically using those right triangle, the Pythagorean theorem, to figure out the missing segment. So what we got here, so slant height, which is square root of 4 square minus root 6 quantity square. So square root of 16 minus 6, then that'll be root 10. Okay, so for the slender height, it's root 10. So the area of the base, then that'll be 2 root 6 times 2 root 6, which is 4 times 6, so then that'll be 24. And then the lateral area of the pyramid, so the lateral area, so then that'll be considered 1/2 times L, the slant height, root 10, and then times the perimeter of the square. So the perimeter of the square, which is 2 root 6 times 4, so 8 root 6. And then multiplying those radicals and also the integer coefficients. Okay, so let me just put it right here. So 1/2 times 8, that's 4. Root 10 times root 6, root 60. And nothing we can simplify at this moment, so this one basically just leave it like that. So the lateral area of the pyramid. So this one is a little bit complicated, so there are certain things that you need to find out first. The diagonal. So once we figured out the diagonal, we can figure out the side length for the square, and also from there we can figure out the slender height, and then using all the information we can get to the lateral area. And once you get the lateral area, we can also get a surface area. So the lateral area plus the area of the base. Okay, so thank you for watching the video today. So if you guys do have any questions, so feel free to put into the comment bar on my YouTube video. Okay, so I'll see you guys next time.